Yeah, thanks a lot. And as I said, now for something completely different after these great Power BI presentations, for something without Power BI, without visuals. My presentation is called The Last Mile is the Hardest. It's about IoT, and basically it's a take on IoT projects, and I've prepared a presentation in Pecha style. And for those of you who are not familiar with Pecha, that's a presentation technique from Japan. And the idea of Pecha is that you have 20 slides, and each slide is shown for 20 seconds and then automatically advances, which gives you roughly a 7-minute, just short of 7-minute presentation with 20 slides, so no text slides, as little text as possible. And it's a bit challenging as it goes for slide design, and it's a bit challenging as those automatically advancing slides can either really rush you if you have more to say on one slide, and really you'll notice how long a few seconds can be if you don't have enough words to say for those slides. So it's a bit of an experiment, but we'll see how it works out. And before I start the Pecha style and the automatically advancing slides, I'd like to do a very short introduction with also my contact information on that slide, and talk a bit about myself. By trade, I'm a mathematician. I did stuff like partial differential equations a long time ago in a previous life. Now I'm CTO of MLPA Consulting, and at MLPA Consulting, which is why I didn't want to skip this introduction, we do IoT projects, and we have our own take on IoT projects because we do IoT projects end-to-end, meaning we also have hardware development, we have hardware production, we have people sitting in front of black screens with white font on it, doing embedded programming, and we do, of course, cover the cloud part as well. And that's why I feel like this is a topic that I can tell you something about, and tell you something about the implications and the decisions to be made when designing an IoT project. And with that being said, I'll kick off the Pecha style of my presentation and start the automatically advancing slides. And maybe those automatically advancing slides, for that reason, it's good that there's no questions and no interruptions, because that's even harder if you only have 20 seconds to answer them. Okay, so let's kick this off and let's get started. If you're talking about an IoT project in the cloud, we've basically got everything covered technology-wise. We've got IoT hubs, we've got SQL databases, non-relational databases, Azure functions, event hubs as glue between all those components. There's a lot to do, and there's high complexity in an IoT project, but the building blocks are quite clear. For sensors, it's an entirely different story. Most proof of concepts are done with Raspberry Pis. However, a Raspberry Pi has rather high energy consumption, and I'll be talking about that later on. It's comparably large, and it has many features on board that might not be necessary for an IoT project. For example, a sound card. I've never seen an IoT project requiring a sound card. That's why we chose to build custom hardware and do custom hardware development, and that's actually an image of our hardware production unit. And our hardware is built from groups of components. It contains a real-time operating system. It contains custom development on the chip, and that has some implications. Now, what is that last mile that I mentioned in my title? Left you have the sensor, right you have the cloud. Somewhere in between you have your telecom provider, and somehow you need to get the data from your sensor to your telecom provider. And that little bit between your sensor and your telecom provider is called the last mile. And why is this last mile critical? It's critical because the design of the last mile impacts the overall usage and lifetime of your devices. Bandwidth, availability of bandwidth can block or enable applications. If you have a very narrow bandwidth, a video streaming application is just not feasible. And the energy consumption can break use cases. This is one sensor design we built for a customer, and you can see that the battery is rather prominent. And this is because the requirement is to have our devices mobile, and having a mobile device where you don't have the possibility to add new cabling requires batteries. And recharging is often not an option. And why is it not an option? It's not an option because other than in the data center, what contributes to the operation costs of an IoT device is mobile costs and maintenance costs, and maintenance includes changing the batteries. And now I've pulled up a quick calculation to give you an example to understand why changing batteries can be bad. Assume that you have 10,000 devices and need 30 minutes to change the battery in a device. That sums up to more than 200 man days just for one battery life cycle. So if your battery lasts 1 year, you'll have one full-time employee just for changing batteries. And that plus you have travel and shipping costs of your devices, and that cost can break the TOC for an IoT application. Same goes for mobile costs. And since if you have every sensor equipped with a SIM card, this will surmount to very huge mobile costs. And that's why we typically choose gateways to handle communications. And behind the gateway, we need to have, as our devices are mobile, some kind of radio technology that uses little energy and enables communication of data from the device to the gateway and then to the cloud, and information from the cloud through the device to the gateway. So if we're talking about the last mile, really what I'm talking about is the choice of the radio technology between the sensor and the gateway. And the choice of that radio technology is really important. And there are several radio technologies in the market, and I'll just highlight a few of them. Of course, everybody knows wireless Wi-Fi. Everybody knows that it's an everyday technology, which is one of its pros. However, sending data via Wi-Fi consumes rather a lot of energy compared to other technologies, and the chips you need to build onto your sensor are comparably expensive. Bluetooth Low Energy is another technology everybody of us uses every day, and it has rather comparably low energy costs, and it's again an everyday technology. However, the range of a Bluetooth device, you've all experienced that if you start walking away from your computer with your Bluetooth headset on. And then there's commercial products like LoRaWAN, Sigfox. They're specifically designed for IoT, meaning they have very low power consumption, a very long range. However, they're limited vendors. They don't use open standards, and there are sometimes differences in architecture for different regions, and I'll talk about that later. And then another topic that comes up frequently if you talk about data transmission is NFC, RFID. Those have very low costs, and RFID tag costs next to nothing. They're passive technology, so they don't use battery, which sounds ideal, but they have virtually no range. You need to touch the device to transmit data. And then finally, and we're not at the bar, but at the grill we'll also have a beer, there's homebrew solutions. Which is what we use. We use open standards for communication protocols. We can perfectly tune it to our chip design and low energy consumption. However, the development costs are insane. To give you an idea about energy consumption, what I'm talking about, Ocean, which is one of the commercial providers, uses single-digit megawatt. Bluetooth Low Energy, an order of magnitude more, tens of megawatts. LoRaWAN, another order of magnitude more, 100 megawatt. And now Wi-Fi is in tens of milliwatts, so that's several orders of magnitude more. For range, LoRaWAN has a range of up to 10 kilometers, whereas Wi-Fi specifications say up to 250 meters, but we all know how realistic that is. BLE, 100 meters, in Ocean 30 meters. So also choosing the right technology changes the range and the network topology of your IoT specification. Also, what you need to keep in mind is that radio frequencies that are allowed for use in applications differ strongly by region. So you need to choose frequencies and frequency bands that you're allowed to use in the respective region. So overall, what I would like you to take away from that is be careful when choosing the last mile technology for an industrial IoT application, meaning when you leave the playground zone, because the choice you make can either make or break your IoT application in terms of energy consumption, in terms of range, in terms of network topology. And so really give the last mile a second thought if you design IT projects. And with that, I think I'm well within my time slot, and I can conclude my presentation.